For hundreds of years, two phenomena existed: static electricity and magnetism. These remained unexplained until the early 1700s, when many practical experiments commenced on both electrostatic and magnetism. By the early 1800s, works by Galvani, Oersted, and Faraday on galvanism, electromagnetism, and electromagnetic induction opened up a new field of experimental work which ultimately paved the way of present-day electronics. The advent of the 1914 to 1918 war changed the pace of development, and electronics now covered a wider field of applications. New radio tubes and new circuits were developed for communications, and after the war, radio astronomy, surrography, early radar, and computer technologies were all ready to be further developed during the 1939 to 1945 war. Under the pressure of this second war, radar and computer work led to a great increase in electronics research, and both governments and private industry set up large laboratories. From this came masers, solar batteries, and in particular, in the 1950s, methods of perfecting ultra-pure materials such as germanium and silicon. The stage was now set for the next major advance in electronics, the transistor, produced by Bell Laboratories in 1948, enabling all electronic equipment to be miniaturized. The planar process, invented in 1959, enabled many transistors to be manufactured simultaneously, and the integrated circuit, known as the chip, was born. Because of the massive lead of integrated circuit in a much wider field of applications, evolutions and innovations were being introduced. With that, a system of packaging techniques were introduced, and these became our main topic for this evening, the Flatpack integrated circuit. Flat package is a US military printed circuit board surface mount component package. The military standard MIL-STD-1835C defines flat package is a rectangular or square package with leads parallel to base plane attached on two opposing sides of the package periphery. The original Flatpack integrated circuit was invented by White-Tao in 1962 while working for Texas Instruments. He was working for a component that achieves maximum heat dissipation. One of the main problems of ICs before is its ability to withstand extreme conditions. And generally, flat packages are industry standard for applications operating in extreme conditions and high reliability expectations. So, we now all know the significance of Flatpack integrated circuits, and it's about time to show you its world. Come with us and let's go together and enter the world of Flatpack ICs. In removing Flatpack integrated circuits, we introduced the two methods of removal, the heat gun method and the soldering method. The heat gun method. First, conformal coating is removed, fluxes being applied throughout the legs of the Flatpack IC for easy removal. Second, a heat gun is being applied to the IC. The extreme heat of the heat gun enables the Flatpack IC to be separated from the board. The soldering method. First, remove the conformal coating, fluxes being applied throughout the legs of the Flatpack IC for easy removal. Second, lead is being spread throughout the legs of the Flatpack IC. And lastly, the replacement of Flatpack IC. First, the area is cleaned by a soft cotton using alcohol. This is to clean the area and remove dust and unnecessary components. Second, lead is being spread throughout the leg print on the board. This is to bind the placed IC and the substrate or the board. Lastly, the IC is placed carefully onto the desired leg place.